Hi John, this is the presentation for IHSS CA3 from myself, Brigid, Marmion. The outline of the presentation as we discussed in class today is the use case scenarios. I'll just go through the three that we created. I'm going to talk about our database development, the use case rules, a little bit about HL7 and security and trust at the end. So the specification for our project, we looked at creating a system to log and record a child's immunisation record from birth to 14 years old as set out in the personal health record and as dictated from immunisation.ie's recommended schedule of immunisations for children from birth to 14. We had a system design meeting for CA3 to try and redesign our system and look at it in a more object-orientated way. This was reflected in our database design as well, where we tried to match our classes and our tables as appropriately as possible. This is the overall database table schema. I'm just going to go to the larger version of this so we can see it a bit more. So what we tried to do was normalise our databases as in comparison to, say, Continuous Assessment 1. We refactored our tables in a normalised fashion, so there are two goals of the normalisation process. They make sense because the normalisation eliminates redundant data, so you're able to store the same data in more than, it means that you're not storing the same data in more than one table, which we sort of were in CA1. This is now very defined, where data is stored in a very meaningful way and purposefully in tables, and they're segregated out. We can also ensure that data dependencies make sense. So where we have stored our data in the different fields, they make sense for in each particular table. So a person, for example, has a first name, a last name, an address and a BPS number, and the contact details then are stored separately. And this helped us also with our classes, because it meant that certain fields were confined to certain tables. So we spent quite a lot of time refactoring and redesigning from scratch for this CA, our database tables, and then I'm working out our foreign key constraints and the dependencies. So say, for example, in the very last table there, immunisations received is filled from patient next of kin and immunisations, so there's a definite link there. And then the foreign key for, say, healthcare professional ID is linked to the primary care in healthcare professionals table. Okay, so our database rules, these were very clearly defined, so I might just pop back to that last slide. So the first one was the patient must have a next of kin to register on the system. So like I said, that would form the patient next of kin table. So let me see it go back. So a patient must have a next of kin. So there's our patient table, and that patient has the patient next of kin must have a patient, so there you can see the link, and must have their the CID comes from the contact details ID, which feeds down there to the NID for next of kin ID. Okay, and then the next rule is, in order to verify that the patient has received an immunisation, we need to know the patient's next of kin, the immunisation received, and the healthcare professional that administered the immunisation. So I'll go on to the previous slide to show you how that forms in the table. Okay, so this is our immunisations received table. So in order to implement that rule, you need information from the patient next of kin table, the immunisation table, and the healthcare professional table. So for example, if the fourth entry down, the next of kin is is Ruth, who's linked to FIA from above. She receives an immunisation, so 6-in-1 PVC and MMC, and that was administered by Dr. John Wakely, who was a healthcare professional for that particular for that particular immunisation. We have a couple of healthcare professionals. You'll see in the larger overall database schema where I populated some of them, we had 2 healthcare professionals, John Waitley and Paul Fingleton. So then they could assign, they have an ID number which links them with whatever immunisations they administered at a particular date to a particular child who has a particular next of kin. So it's all traceable, as I was saying in the presentation. There's a clear roadmap. Okay, so that's the database rules covered. Okay, so then we went to our use case scenarios. So the first use case was to register a new patient. Okay, in order to implement the rules, I'm going to demonstrate the use case scenarios, which will demonstrate how they were used in the program. The first use case is to register a new patient. So the description is, John logs on to the system, he chooses to register a new patient. He registers a new patient's next of kin and logs out of the system. So it's quite simple. So the trigger is to register the new child patient. Our actors for this particular scenario are the child, which is the patient, our next of kin, and a healthcare professional. The preconditions are important. John's already registered with the system and the patient does not already exist. So it is a new patient. And the goals are to register the patient and to register their next of kin. So this is the flow chart, as you can see, and I'm just going to demonstrate that with the code. I'll demonstrate all the code at the end just to make it cleaner for you. The second one is to update an immunisation. So the GP logs onto the system, chooses to update an existing patient's immunisation record, so it's slightly different this time. Searches for the patient who's already on the system, enters the immunisation they've received and logs out of the system. So there's the enters the system and exits quite clearly. Again, actors this time are the healthcare professional and the patient who is an existing patient. The preconditions that the doctor is already registered with the system, so they're not logging on for the first time, and the patient is an existing patient. This is the flow chart then to follow the procedure as it was implemented in the code, and again I'll explain that when we go through the code. That was be the use case demo. So scenario 3, this would flag which immunisation is due next. So doctor logs on to the system. He wants to view patient's immunisation to see which immunisation is due next. So it might be patient mightn't know necessarily, especially with the 3-month and the 2-month immunisations, they're very close. And the 12 and 13-month immunisations are very close also. So the next of kin might remember. So just as a double check and a verification. So the 2 actors are the healthcare professional and the patient in this story. And preconditions again, doctor is already registered with the system and the patient is an existing patient who've already got an immunisation history. The flow chart as the code was written is developed there in front of you, and again there's a clear entrance and exit of the program. So we used standard terminology in our project. We weren't able to implement SNOMED. We used the tables from immunisation.ie. I'll just bring up that table so you can have a look at it. Okay. So here's the table from immunisation.ie, which has a list of the ages that a child is to receive the various immunisations and the vaccine name. So there's your descriptor that we used and put into our database tables, which I'll go through later on. Okay, so the interoperability and advantage of HL7.